More logarithms. We have two special types of logarithms, and we call them the common and the natural logarithms. They speak specifically to the bases of the logarithms. A common logarithm is implied that there is a base of 10. So in the question to the left, we can rewrite this. You don't have to, but it might be helpful in the beginning to rewrite this with a base of 10 of 900. So this question is saying, evaluate the logarithm base 10 of 900. So for this one, we're going to have to go to our calculator. On your calculator, you will find a button that says log. The button on your calculator is the common logarithm. Therefore, to evaluate this, you're going to hit the log button, and then you're going to hit 900 and enter. And you will get approximately 2.9542. So what does that mean? It means that if we were to write this in exponential form, the base of 10 raised to the exponent of 2.9542 is approximately equal to 900. Now, we've always been working with exponents that are integers, but the reality is not all exponents are integers, and that's why logarithms are necessary. Our other special logarithm is called our natural logarithm. The natural logarithm is a log with base e. If you remember from an earlier video where we talked about compounding continuously, e is actually a number. You can think of e as something similar to pi. It is a button on our calculator, and instead of writing log base e, it's actually simplified to be the natural logarithm, and it's written ln. So that means that this question of the natural logarithm, I can rewrite this as log base e, and then this e is part of the question. What I can do to simplify this is imagine that we have an exponent here. And if we have an exponent there, it would be an implied 1. Remember the rule that we talked about earlier, that any time these two numbers are identical, so in our case, they would both be e's, that the answer is actually the exponent. So in our case, these two numbers are identical, so this is going to simplify to be 1. If you write that in exponential form, e to the 1 is equal to e, which is a true statement. Solve equations with logarithms. What I'm going to do to simplify this question is I am going to look at the base which appears on the right-hand side of this equation. Because I want to simplify that base of 10, I'm going to insert the common logarithm. And whatever I do to one side of the equation, I'm going to do to the other side of the equation. Then I'm going to write the question that was given. So 10 x minus 1 and 25. Now the reason that I'm doing that is because of the rule that we just used in the last question. As long as the base is the same, what we can do is we can simplify this so the right-hand side will now equal x minus 1. So on the left-hand side, we have log 25. Notice that I dropped the 10 because it is our common logarithm, so I don't need to write it every time. I want to solve by getting that x by itself, so I'm going to add 1 to both sides. then I'm going to go to my calculator. So x is approximately equal to 2.39. I'm going to solve this question as well, and the x that we're solving for is inside of the parentheses. So the first thing I'm going to do is I'm going to write this as log base e, just so you remember that we actually do have a base number here. Then I'm going to change this to our exponential form. So I'm going to write this as e to the fourth is equal to 2x plus 3. Now remember, e is a number. So on the left-hand side, we have a number. To get x by itself, I will subtract 3. So if e to the fourth minus 3 is equal to 2x. And then to get x by itself, I'll divide both sides by 2. E to the fourth minus 3 over 2 is equal to x. Then I'm going to go to my calculator to get an approximation. Don't forget to put parentheses around the numerator, otherwise your calculator may give you an incorrect answer. So the answer is 5.799.